Hello, sports fans. Today we'll look at the surface area of a cone. Earlier this week, you learned how to compute the volume of a cone. So today's agenda is going to include not only the lateral surface area of a cone, but also the total surface area of the cone. So let's start. So a right circular cone, that's what we're working with again today. And we're going to be finding the lateral surface area and the total surface area of these things. But first we need to point out a couple of parts. We already know what the vertex is, but that's not used in the formula. What will be used in these formulas are the radius of the cone and height, which I have mislabeled, is the height of the cone, also known as its altitude. So the altitude is at right angles to the area of the base, or the base of the cone. So those are the important parts. So let's go and look at a quick example. So we're going to find what's called the lateral surface area of this cone. So there is a circular bottom to this cone. So lateral surface area does not include the circle. It only includes the cone part. So imagine an ice cream cone turned upside down, but there's an opening in it right here. So we're just figuring out the lateral surface area of that upside down ice cream cone. So the area formula for the lateral surface area of a cone is the product of pi, you multiply pi, and the radius and the slant height all together. So that gives us pi times the radius times the slant height. So notice the dimensions are given in centimeters. So at the end we want to make sure that it's an area, so the final answer will be in centimeters to the second power, or square centimeters. So let's figure out the exact answer first. So that would give me pi times the radius. So the radius is right here is listed as 8. So this piece of the puzzle is 8. The next thing I need is the slant height, which is the distance from here to here. So going from here to here, we see as 10 centimeters. So multiply that by 10. So when all of that gets multiplied together, it becomes 80 times pi. So 80 pi. Now, if we wanted to, we could go ahead and substitute 3.14, as we often do, for pi. And what that becomes is 200, let's see, my calculator says 251. This is definitely a calculator problem. You're in high school algebra, so we know that you know how to do multiplication. So 251.2. But I'm not quite done yet because we have not put the units with it. So the units will be centimeters squared, also known as square centimeters. So let's look at this same figure on the next slide, and we'll add in the base for a total surface area. So in order to figure out the total surface area, so notice here we have total surface area. Before we just had lateral surface area. So we're going to do total surface area, which means it's the lateral surface area plus the area of the base. So now my ice cream cone has like a top on it. So same sort of entries again. We still have 8 centimeters. Still have 8 centimeters here for I erased a little of that. Still have 8 centimeters for my radius. So this piece here is the radius, and it's 8 centimeters. And this piece is the slant height, and that is 10. So remember, the slant height is the L piece here. So once you have your formula, all you have to do is substitute, let's go pi times the radius of 8 times the slant height of 10 plus pi again and the radius squared. So we already figured this part out in the previous example, and that was 80 pi. And this, when I square 8, I get 64 pi. So I have 80 pi plus 64 pi, which gives me, let's see, 144 pi. And again, it's centimeters squared. So usually what we do, remember, this is not that meaningful to us, even though it's the exact answer. And when you get to like pre-calculus or calculus, a lot of times we just leave pi as pi. But here we're going to go ahead and substitute 3.14. So that would equal 144 times 3.14. So that you would use a calculator for. And my calculator is telling me that that is about 452.16 centimeters squared. So the final answer for total surface area, again we went with total surface area that time, is 452.16. So notice 452 for total surface area is more than 251, which is only the lateral surface area. So we're adding on to that. So it's going to be higher than this 251. So some will see this as sort of a trick problem. And that's why I wrote trick in quotes. A trick problem. Have a cone here, and we're going to find the lateral surface area of the cone. But notice we do not know what this piece right here is. We don't know the lateral, or we don't know the slant height of this cone. So we have to find some way to figure that out. If only we could do that. And the answer is, yeah, you betcha we can. So another common mistake I will see students make is they'll see the 4 and the 3 here, and they instantly go into finding the formula, right, that we covered earlier this week, which is 1/3 pi r squared times the height. But it says find the lateral surface area. So we need to figure out what this height is. So do we notice that this is a right triangle, and one leg of the right triangle is 4 and the other leg is 3. So that tells me that this must be 5. Because I recognize that this is a 3, 4, 5 triangle. It's a Pythagorean triple. If you forget it, just go over to the side here and do a little, where can I go? To the side. 3 squared plus 4 squared has got to equal the L squared. So that's 9 plus 16 equals L squared. And add these together, 25. That equals L squared, so L is 5. Plus or minus 5, but we're going to go with the plus 5 because it's a length. All right, so everybody's good with this being a 5. So now I can go ahead and figure out my lateral surface area. So I'm going to abbreviate that, LSA, lateral surface area, because mathematicians are lazy by nature. So that becomes pi times the radius times the slant height, which I now know. This is the L. Let's see. Pi. My radius is 3. My slant height is 5. So that becomes 15 pi. And again, because it's an area, it becomes square centimeters. But if you want to know an approximation, just substitute 3.14 in place of the pi. So 3.14, there we go. So it's that many centimeters squared. And when I do that, I get an approximation. I should kind of technically be showing this as an approximation, but it's not really important. So it is 47.1. And that comes from my handy dandy yellow box of magic. So there you have it. We really quickly, we talked about lateral surface area. Then we added the area of the base on to get the total surface area. And then we did a kind of a quote-unquote trick problem where we were not given the slant height. So we couldn't figure it out until we figured that this was a 5. So we could not figure out lateral surface area until we figured out that L was 5. So there you go. Short examples there. Stay tuned for some other problems next Tuesday. All right, I hope you like those additional cone problems. So won't you please give the video a like, or better yet, go ahead and comment down below and let me know any topics that you would like to see covered. Thanks again, and I appreciate it so much. So until the next time, don't forget, math is not a spectator sport. The only way to learn math is to do math. So until next time, this is Noldy signing out.